Please welcome Don McGookey.
Thank you. Excuse me if I talk from sitting down. I'm wired all over the place. Just a brief introduction. Doris and I bought some acreage. Well, first of all, I was a geologist with Texaco for 27 years. I was chief geologist for them. To prepare, I had BS from Bowling Green, a master's from University of Wyoming, and a PhD from Ohio State. We lived in all parts of the Rockies. We started from masters. We went to Lewistown, Montana, and then I went back to school for 3 years to get the degree. Then it was Casper. Oh, and during my dissertation area was in the middle of Utah, in the high plateaus of Utah. So we lived there for a while. Then to Casper for 3 years, then Denver for 3 years, and Farmington for 3 years, back to Denver, and from there to I had an office on the 27th floor of the Chrysler building for 3 years. I was on a special group that answered to the chairman of the board and overlooked exploration and exploitation worldwide. What I'm trying to say is I've had a lot of exposure. My whole life has been a continuing education. We bought this acreage just because it had a good view, and then later when we started living there for a while, I said, my God, there's a lot of interesting geology around here. So I started studying up, and fortunately at that time the University of Colorado and the Colorado School of Mines both had masters and PhD students all over South Park. And they published the work about the end of well, it would be late 1990s. And so I had the privilege of having all this new work by these people, plus the USGS has a fair amount of work that they've done up here. So I started putting it together, and this is how I came up with the geologic wonders of South Park. It is a very fascinating area. I put this first slide on, namely to show you what fun writing a book is. This is a mountain sheep on the west side of London Mountain. And I understand there's a whole herd of sheep up there. I've often said I got to go up there and visit it, climb to the top and see that herd, but I never did. I flew over a few times and didn't see them. I was always concentrated in the geology and never thinking about, well, I got to see that herd. Anybody ever seen the herd?
Yes.
Huh?
Yesterday.
Oh, right, yeah. How many of them are there?
I think in the group that we saw there was about 20.
About 20, yeah. Well, this guy, I was studying the outcrop along the Mosquito Pass Road, and it was just on, as I say, the west side of London Mountain. He stood there and checked me out, I think, for at least a half hour. And he just, apparently it was quite a curiosity to him. for all the work we did there, Doris, my book has road logs on all the main roads of Park County, and everyone's fascinating, by the way. Doris did most of the note-taking and keeping track of the mileage and all that stuff. And another fellow named Charlie, Doris, help me out. Well, anyway, oh golly, I'll think of it. I'm 91 years old, so I sometimes have a little mental block. But the book is dedicated to him. Oh, I can open up the book right there. But anyway, he had a four-wheel drive, and we'll see a lot of pictures taken from some really weird angles.
Charlie Wagner, sir.
Charlie Wagner, thank you. Appreciate it. I need a lot of help. Charlie's wonderful. Unfortunately, he's no longer with us. But going to the top of Ross or going up the Mosquito Pass, we always used his four-wheel drive unit, so he was a great contributor. Anyway, I just want to get some of the flavor of the fact that writing a book when you're studying an area like this is pure joy, because everything's just fascinating. We'll get on. The rock there is a Pennsylvanian quartzite, and some intrusions. I think the sheep is standing on an igneous intrusion between the layers of quartzite, to give you some idea. And this course is from the top of Ross, looking down on Kite Lake, and another beautiful view. You probably can't see this too well. This is a geologic column showing the Precambrian here, and then blowing it up. Now this is going by from 4.6 billion years to 540 million years. It's what they call the Precambrian. And most of the rocks in South Park are in this section right up here called the Proterozoic. And there are three different intrusions of granites. The first granite is about 1.7 billion years old and very distinctive. All you have to do is walk around this town. You'll see samples of every one of these. And as soon as you recognize their hand print, this one here has crystals of plagioclase it's an orthoclase, a light-colored, sort of pink, almost flesh-colored, and the crystals are about an inch long and about a quarter of an inch wide, and it's just a whole mash of them. You will recognize right away. These other two are sort of lighter colored granites, a 1.4 billion and then a 1.06 billion. That actually is about the age of the Pikes Peak granite or batholith that you go through every time you go from here to Denver. You go through a northern part of it, and on 24 you go through a southern part beyond Florissant. the section changes at 540 because this is when you start having fossils with hard parts. And the hard parts, of course, are either calcium carbonate shells or chitin shells, like your fingernail. All your bugs have chitin shells, but they get preserved in the record. From 540 million years to about 240, that's the Paleozoic, the early part. And the main thing, we have the whole section. I'll be pointing out a quartzite, the limestone, and I'll say, well, there's a cave in this limestone that's really interesting, and there's all at London Mine and other places. They get a lot of gold in this quartzite down here, and then you get up into the red beds up here in Pennsylvania, and this is a mountain building time from about 320 to about 290 million years ago. It's called the Ancestral Rockies, and we'll see where that's really important and where it comes to the surface. And that quit right about that time. This is also the time when the Appalachian mountains were formed, primarily. There were some older formations in the Appalachians up in New England, but in the southern part and then in Texas, in that area, where we have continuations, so it's all in this thing. I'll show you a slide on that. Then there's a big area, there's nothing, right? We have no Triassic in this. We do have Jurassic and the rest of them out here. Mountain building, first mountain building in this area is about 72 million years, and then there's more, about 70. And again, in early part of the Cenozoic, and last mountain building was about 25 million years ago in the Miocene. Glaciation up here in the Pleistocene, we'll mention that a little bit. Volcanic activity was primarily from about 35 to 25, somewhere in that range, so a million years ago. This is a physiographic map of Colorado, and this is usually computer generated from topographic maps. On maps, I'll have the outline of Park County, and in this particular area, what I'm trying to show up is Park County has 4 sides. It's about 50 miles across and 90 miles long. This is a very large intermountain basin. The west side's the older side, and it's from Mesquite Range, and then there's Buffalo Peak about here, and then Kaufman Ridge. This is a trough over there that Buena Vista sits in, and you see it comes down to here and then jumps down here and actually goes clear down to El Paso. We'll talk about that later. These are some of the major faults in the western part of Park County. The northern part is younger, from about 70 million to as young as volcanic activity about 18 million years ago. Climax molybdenum, which is right off the corner here, is about 25 million years old, and we'll be looking at a rhodochrosite, or talking about it. I don't have a slide on it, unfortunately. Here, that's also 25 million years old. The east side is the west side of the Front Range, and the Front Range actually comes up like this on both sides. Toward the east, the eastern fault is east of all those beautiful the red rocks and the beautiful rocks in Colorado Springs. But they are all located right in here, and right east of them there's a very big thrust fault that comes up and swings the whole eastern out over the parts of the Denver Basin. The same thing happens along these faults here, except we have an area right in here under the arrow in the Elkhorn Hills area that's rather unique. It is an overthrust fault. And the three types of faults are normal. Normal, one side goes up and the other side's down, and the angle is towards the downside. In a thrust fault, it comes up and the angle is towards the upthrown side. And in an overthrust fight, the rocks actually act like a big landslide, and they move up on some sort of base that's lubricated, and they'll move, in this case, they move 7 miles out over the eastern part of the South Park Basin. And then the South Park here is a big volcanic pile. Drainage went down this way up to the time that the volcanic pile, this plugged up all the drainage that used to go up down here into the Canyon City area, and of course developed a new drainage pattern. It cuts diagonally across the Front Range. And I'll try to explain it. It's not an easy job, but it's all a matter of superposition. And so we will talk superposition for a while. Some of the road systems here that you recognize right away, superimposed. This is another map that the county made. And I don't think it covers all of Park County, but again, the volcanic area you can see the west flank of the Guffey volcano, then the north flank, and the east flank over here. It's all eroded to heck down here, so you don't see that very well. But very fascinating. That western side now is, this is from Mosquito Pass, and looking off to the southeast, so that's Mount Albert over there, and Leadville's just down the hill here. And this is the big fault on the west side of the Mosquito Range. The peak over here is, what is it, Albert, something like that. These rocks are very highly indurated. They start out as sandstones, but when they get caught up in all this activity, this structural movements and squeezing and everything, the water gets into the pores and causes them to become quartzites. And there's quartzites here, and there's also some intrusives right along here at Mosquito Pass. The section here, well, the other thing is, you notice that these rocks go up and then they start to drag over. That means that this fault went up, this side went up and dragged against this side when it over-thrusted it. The thrust zone along the Kaufman Range and this whole area right through here, and we were up. Let's see if I can get it right. This doesn't really get far enough west to see all of that. This shows some of the areas of igneous intrusion. This is Mount Bross here, and then you have Silver Hills, and we'll be looking at one right outside of Como right here that's fascinating. And this is a big Boreas intrusion. When I made this slide, I thought it was a stock, and then the fellows from Colorado School of Mines studied it, and they figured it out to be an extremely thick sill. Sill is something that comes in horizontally between layers of rock. This would have to be an awfully big. Usually these things take a circular bubble type shape, and when they bubble, then the rocks on the either side are on and are pulled up with it, the sides of the bubble. Well, you don't find any of that around here, so it's a head puzzler. The situation here with Park County, and we'll be talking about these mines right in here, London Mine, and Bross, and that area. It's part of a Colorado mineral belt is what it's called, from Telluride, just west of well, here's Telluride, but west of Durango, clear up through Gunnison and Aspen, Leadville, Climax, Breckenridge, Georgetown, Central City, and on into Boulder, where it hits the edge of the Front Range. The black dots are all areas of mining. It can be more than one mine. The round dots are towns, so I'll tell you what it looks like. But we are right in this area. We're right in the edge of it. Like I told you, I had bought a house that sits on a hill looking northwest. My house would be right about there. And I'm looking at northwest at the Mosquito Range, and I'm looking right into the heart of the Colorado mineral belt. This is sometimes described as a geologist's paradise. And but at any rate, this is a close-up of part of it. Now, here's the London mine. This is Mosquito Creek right here, Sacramento Creek and 4 Mile Creek, and Sheep Mountain right here, and Pennsylvania Mountain right there, Bross over here. Well, Bross is right up here, excuse me. This Pennsylvania Mountain right there. There's the big London Fault. You'll see several pictures of it as we go along. It continues on southeast of Sheep Mountain and southeast of 4 Mile Creek. almost to the highway. And then it terminates right about at the edge of the mountains of the Mosquito Range right up here. London Mountain, the south part here and the North Mountain here, north side, it was extremely rich gold mine. And I don't know when it first started, probably back in the late 1800s, but it was still going in 1990s. And last I heard, when you go to the South Park Museum, South Park Bar, and you get all the latest information. Is that they were taking about $7 million worth of gold a year out of it, and but the main place they were coming in is on this tributary to Mosquito Creek, and they had some big dumps up here that had water in them, and they had a real wet spring, and the dams broke, got into the Mosquito Creek, and bothered the trout quite badly. And EPA or somebody said, "Oh, you got to shut that thing down." So I think that was the main reason. Rebuilding all that stuff was probably too expensive for them. But there's probably still some gold there. They said that there was up to 100 miles of tunnel in that distance from about here to where it says North London up in here. The gold is brought up by hot water along a fault, and it'll attack either side. The east side of this is all Precambrian metamorphic rocks. It doesn't attack real good. On the west side you have sedimentary rocks, and it'll eat out caves in there and deposit the gold, or if there's limestone, it'll have a chemical reaction and it'll precipitate the gold. So the limestone really is the easier one to work with, and usually there's a gradation from the fault into the country rock on either side, and the gold comes up with the hottest water, and then as it gets farther away, it'll deposit silver, and then it goes into copper, and then it goes into lead and zinc. So you have a halo around these things that you deal with when you're mining them. It's very fascinating. This is a picture of the North London mine. You can see the Precambrian rocks here that are being thrust up. And these rocks here are all Pennsylvanian sandstones, which have been turned into quartzites by the water effect out here, so close to this thing. And if you look real closely, they're dipping off to the west here, and then dipping very steeply to the east, right next to the fault. That's called drag. And when it drags up, it drags some of it back down. We'll see a cross section in a minute. This was the portal on the north side there. And then they had a tram that went down to a mill down in the Mosquito Creek Valley. Here's a cross section of it, and you can see the rocks coming up and then coming up steeply, and the fault this side moving up quite distance. This is Loveland Mountain, and when you get over there, you go across the Mosquito thing, and you see the same rocks on the top. And Loveland has quite a few prospects and also quite a few good mines. And of course, they had trams that came down into Buckskin Gulch, and you probably all seen the mill that they have up there. It's still in pretty good looking condition. We're moving to another thing here. Where this you may not recognize it, but this is Fairplay. And right about here is the only stoplight in Park County. So this is 9 going up, and this is 285. And this is Silver Hills. And Silver Hills has a lot of ridges in it like this, and those are all sills where rock, where the magma has come in between the layers of rocks. There's part of it's light colored. You can see up here. Wherever you see the top here, there's a sill there that makes that particularly resistant to erosion. The rocks down here are a continuation of the red pass over here. We'll talk about, I got pictures of that later going on. Fairplay itself is just downhill from the youngest glacial stage, which had a maximum about 25,000 years ago. But you see here a bunch of trees here, and then we're right over here. You see there's sort of a terrace there, and then it drops off, and we're just at the base of that terrace. You walk out the front door here, and you go up to the park, and the park's all full of large boulders. That's an older glacial terminal moraine that's been worn down to a point where it's almost flat. And but the boulders give it away. That was what they call the Illinoisan about 150,000 years ago. Then, right down in the corner next to that stoplight, the fellow that built all those the stores down here, Prathers and others, he dug a huge gneiss, what I call a gneiss. Now, a gneiss is a type of metamorphic rock that looks almost like a granite. And if you stop and look at that rock, it's monstrous in size and bigger than anything we see in any other. But that one is probably about 350,000. About 350,000. That's right. Years ago, it's part of an earlier glacial front that got farther out than the next two ones did. We're going to go for the east side for a while here, and this is what the Elkhorn Overthrust. It's 7 miles in that little yellow arrow. And we'll be talking about Red Rock Ridge and Reinecker Ridge. And again, this little thing right here outside of Como. But there was the west side of the Front Range And there's a fault that was covered by volcanics down here, but it comes up like this and then continues on and continues up the east side of the Blue River Valley and everything. But this area, for some reason, from the Kenosha area up here, there was a giant landslide. And I mean giant. This is several thousand feet thick, and it looks like this. I'm standing on well, I get complicated. Notice the east dip on all these rocks out here. This is part of that earliest structuring clear on the other side of the Arkansas River and west of Buena Vista, including Princeton and Yale and Missouri and Antero. That was part of a huge anticline back about 75 million years ago, and it affected all the rocks clear over to here. And then all these rocks, and these are fairly young rocks. By the way, they all contain a lot of volcanic material in them. You go down Elkhorn Road, boy, anytime you want to have fun, stop at any outcrop and start looking at the rocks that are involved. They're just, that road is just spectacular. Here it is, right here. It goes up here and goes out over. Okay. When you put the overthrust in here, this is where it is. It's a low angle. Let's see if you'll see a picture of it later. But this is South Park Formation. This is a late Cretaceous and early Tertiary, and mostly continental type deposition. There's no marine section in here at this stage. But a lot of layers that have a lot of igneous in it that makes them harder. Underlying this whole area here, there's, again, Park County. There's an old, I showed it in that time scale that from about 320 to 290, there was mountain building in this area. And they're called the Ancestral Rockies. This is Uncompahgre, this is Front Rangia. And you know, you got red rock, and the outcrop here, right, a fair play of red all around here. That's rock that's deposited by streams eroding off these mountains here. When you look at it on a full scale, here's Front Range up here and Uncompahgre, and then you have all these different basins in here. You get down here in the Midland Basin, and you got the Delaware Basin and the Midland Basin. You got Anadarko Basin, you got all these different mountain ranges. They all formed because this whole part of the continent was moving towards in sort of a swinging process, moving towards Africa. And here's part of South America here. This is where the Yucatan was before it broke off, but South America came right up into here. Africa, well, the rocks underneath Florida are actually originally were parts of Africa before this is that great get-together at the end of the Permian, and where South America came up, Africa came over, and Europe came down, and you formed the Appalachian chain, and then a Ouachita Marathon chain, and there was no Mexico at this time. This was the edge of the continent here, and then this stuff is just coming in to collide with it, with a big continent-to-continent collision to form these mountains along here. But all these are because when you put a twist on the plate, all the lines of weakness will start to break up, and the strength will come up, and the weak ones will go down, and you get formings of basins. This is Central Colorado Basin. This is the Paradox Basin. And then this is the Front Range area, and you had the area east of there, and the Denver Basin area. But in cross-section from Kaufman Ridge in the west, the purple here is all Precambrian, granites and metamorphics. This is all Paleozoic rocks. And go back a little bit. You know, it's Hartselle right here. Hartselle's sitting right on the edge of where the ancestor Rockies came through. Fair Plays, you know, just down the flank on the west side. And you come over here and Woodland Park is right about that age, and this course now is part of the younger Rocky Mountains, but in the old days it was just north of Woodland Park, in that area. If you go north to Woodland Park, the road up across the river, you can see outcrops of the red beds up in there. This cross section of it, and you can see this is Red Hill. This is just outside of town here, and you got a very thin section of Paleozoics left, but you have a very thick basin here called the Colorado Trough here, and these are some of the older Paleozoics. In there you'd have layers of salt because occasionally the ocean did get into the trough, and you had salt flats develop. And of course you got the salt works up here by Antero Junction. You got Salt Creek over there. That's where these things come to the surface, right about in here, and cause some leakage of the salt. Also, when you go east of Antero Junction and past the Hall Buttes, you see some crazy dips to the rocks. They don't all go to the east like they should. Some of them go in a different direction. Part of that is salt flowage. And there's a Black Mountain that you go by on 285 coming this way. On the north side of it, there's actually some deep pits where salt dissolved out and let a big hole in the ground. It's called the Antero Syncline. It's got the Antero Lake, of course, in there and everything else. Tertiary line on the east side of this thing, and we'll be seeing that in a little bit. Just a blow up of this area showing where Hartsel is, and Winter Park, and Red Rocks, and Boulder, and Canyon Creek down here on this thing. Regardless of how you look at this basin, there are two prominent ridges here in the northwest part. One's Red Hill, and goes down to Hartsel, and sort of peters out down there. And then there's Reinecke Ridge. You see, it's quite a linear feature. And that's basically because he follows that old fault that comes right up through here. And we'll talk about that later. I hope you all have plenty of time. There's a lot to cover. But this is Red Hill, and this is 385. And you can see this is a maroon formation. And right about here, from there on east, there's no maroon. It's really fascinating to look at how sharply it goes out, but we have evidence for that. And the rocks in here, these are Permian and Pennsylvanian, Upper Paleozoic. Then there's Triassic should be in here, but there's no Triassic. This place was all exposed during the Triassic. And the first thing you got in here was some sort of Middle Jurassic beach sands called the Jelm Formation. And you can see it makes a layer, since it's sandstone, it gets the water real good, and so you have a layer of vegetation. It gives you a vegetation mark all the way around it. And then here's the Morrison Formation. The Morrison Formation, and of course up in Wyoming, is one of the big, well, in the northwest part of Colorado too, one of the big dinosaur fossil bearing. Most of that Morrison is lake beds and fluvial or stream deposits. And then you have what they call the Dakota sandstone here. And you recall, as you go down the road here, you see these beautiful outcrops of nice bright tan, light tan sand. It should make you want to go and have a picnic, because that's a million-year-old beach. And if you go up here about halfway to Hartsel, there's a road goes up to the top of it, and a beautiful area for looking at the whole basin up there, by the way. And you can have and it's an outcrop of the same sand, so you can see we're going to the beach today. And then you go into marine shales here, and there's some limey beds right above them. But again, see the 20-degree dip here. It's pretty steep. Maroon Formation, this is west of the 9 as you go down towards the river from 285. Just outcrops of some stream deposits, the sandstone, excuse me. And but most of it's just plain old red mud and sand. It probably was a swampy area. Well, it's hard to tell exactly what the climate was, but it had an awful lot of iron in the soil, so it probably at times was pretty sort of like Georgia. Georgia's known for its red clays and all. Sort of a wet area, semi-tropic, but there's times during the Pennsylvania when you were probably only about 10 degrees above the equator. The equator went through Texas at that time. Again, this is just north of Hartselle as you're coming up 9. And when you see these different layers, you can see the red beds here, and then the Trotta sand will make a little bench, and then the Morris will show a little weak spot, and then the Dakota sand will cap the hill and make a big thing. Here at Hartselle, I've given a couple talks down at Hartselle because I find it's such an interesting area. It's folded all to heck, and here's the ancestral Rockies cropping out. You see, this whole mountain in here, and here's the gel on the flanks of it. And the Morrison, and then right over here would be the Dakota, but there's some faults that go through here, and the one that goes along the front of this thing, and of course this was old Sam Hartzel's hot water spa right there. So there's apparently a seep there. Hot water along one of those faults, but just south of there, if you go on 53 off 9, it takes off about 10 miles south of Hartselle, and goes off towards Salida, and here's one of those outcrops of that ancestral Rockies, and this happens to be a granite, which somebody's got the date on it. It's one of those 1,400 million-year-old granites. This is a electric wire going across here. Again, as I say, stop and look at them. They're fascinating. Well, we're going to go up into the start of the volcanics for the south side, and the start is an unbelievably violent explosion of a volcano just northwest of Salida, about where lake, what's the lake? Something. Pardon? Antero, yeah. Right in that area, there was a volcano that had a monstrous, unbelievably destructive explosion. These are what they call ignimbrites, and they're rocks that come out of the volcano in a huge cloud, and in this case, apparently the prevailing winds caught the cloud and moved it off to the east. And as it settled out, of course, it incinerated everything that it touched, and it left very, very hard rocks and some of them very beautiful. Here's the castles as you go down to Buena Vista and look off to the south there. You see these vertical walls, and when you fly over this thing, you see it, they line up towards the southwest, towards that volcano. In other words, there was a deep valley here when they were deposited, and this material came down the valley, and it was, semi-liquid, and you get that effect on either side where you get friction against the side where things will make little eddies on either side, and this they actually just painted a wall on that each side of the valley here, and very, very thick deposits. See, the source is right about here, Salida is right here, and Buena Vista is right here. And the source is right about in here. And it came up and blew to the northeast and incinerated a 50-mile wide area here. Everything in it would be killed. And this Castle Rocks, the top of Castle Rocks, the same unit that you're looking at all along here. And this is showing some of the outcrops along 24 and 9 here. But a little place like on either side of the Florissant area, Lake George area. But here's one that's on the outcrop. And one of the subdivisions down here, south of Hartselle, is on an outcrop of that stuff. But once you see it, you recognize it. It's a fascinating rock. Now, this is getting down into the volcanic area. And you can see the north flank and the west flank, and the east flank's a little more eroded. There's the argument about whether this is a caldera or not. And the people from Colorado Mines say no. But it's hard to believe you get something that clearly outlined just by natural erosion. There actually are 3 different layers of volcanic activity right down in this area. 2 of them are older than this one here. This is all we're looking at. Here's Hartselle, and 30 now. Here's Guffey. This is the part that's all eroded away. But you see the Florissant, and you see outcrops of it as you go down to Cripple Creek, here and there. The most of it is mud flows. And mud flows also are very damaging. Philippines had a volcano, Mount Pinatubo, that I think it was about 2003 or something like that. It blew. And USGS was over there. They had taken their lessons from the volcano in Washington and St. Helens, and they predicted exactly when that thing was going to blow, and they had evacuated some 200,000, 300,000 people away from the flanks of Mount Pinatubo. And by the way, the day it blew, the whole area was hit with a typhoon at the same time. You talk about getting a double dose, you know. But at any rate, the people all went back in there, and then every time there was a monsoon came through, it would knock off mud flows coming off, and the people were all back, and a lot of them got killed. I think there was something like I don't have a real good figure, more than 200 anyway. There was another mud flow like that down in Columbia that came down off the west side of the mountains there, and came down through a valley and killed 22,000 people in one fell swoop. That was back in, I think, about 75 or 80, something like that. But they can be very, very deadly mud flows, and practically everything you see up here is a mud flow, but there's also some layers of real hard rock that represent another explosion over there around Antero, and so that there would be another, not as big as the first one, but a layer to give you another timeline over the whole area. This is from Route 285. We stopped one day. Getting a picture down there is very hard because it's always foggy or smoky or something. This is about as clear as I could find it. But this is Black Mountain, and you can see the western slope of the volcano here. And this is 39 Mile Mountain, and this is Saddle Mountain over on the east side. It's 39 miles on the north side, so it's dipping towards you. But the whole area is about 16 miles across. And when you take a volcano from Kamchatka, which my son did, he's also a geologist, by the way. And here's Saddle Mountain, here's Black Mountain, here's 39 Mountain. And this is a pretty good idea of what this thing looked like. It was a very explosive volcano. And when it explodes up here, it throws out a lot of huge pieces of lava, and they call them volcanic bombs. And so if you look at glacial deposits and then go down here, you say, oh my God, there must be a lot of glaciers around here. There are all these big rocks with a mud matrix. But no, these are all from a volcano, and they are. Here's one in the Mediterranean. I've got a mental block. I can't think of the name of it. But this thing continually blows. Every night you get a thing. But you see the rocks coming down, and then they go down the flanks, and they're still hot, so you get a stream of red going all through your photo. This is the north flank. This is north of Guffey, but I went on a ranch west side of Route 9, and went up the hill a bit so I could get a picture across. And this entire area here is probably somewhere around 3,000 to 4,000 feet is all layers of mud flows. And occasionally in here you'll find an ignimbrite, like I said, but most of it's all mud flows. This is what it looks like, and so you can see this nice little, my wife wrote a book about mud flows and such. She called this guy Iggy. Iggy starts out in a volcanic pile like this one, only we were thinking about the Davis Mountains in western Texas. And he goes through a lifetime, several million years, and he travels down and he gets caught up in all kinds of floods and different things, and he ends up as a grain of sand. He gets worn down in Padre Island. And that's called the rock family. And I'm giving Pat 3 boxes of her book, 30 books to a box, to spread around in the libraries and so forth. But anyway, you see there's little rocks and thing, and mud matrix. These things travel as high as 100 miles an hour when they come down. Here's on 53, going off to the southwest, another outcrop of it, but in this particular one you seem to have a little bit different color, a little more iron in the mud, and all. Okay. Now we're going to look at a different kind of deposit. You all, of course, recognize Buffalo Peak. This is a fen, and it's a conservation area. How many of you have been out to it? Yeah, you know, it's only about 10 miles out, and on the south side of the road, and it's a really fascinating area, full of birds, excuse the expression, and bugs, and especially horseflies, or flies that bite. There's a fellow published an article on this particular area, and he said he was out here, and the flies got so bad he ran to his car, and he had the windows up, and he said they were in the car, and I was going 60 miles an hour, I couldn't get rid of them. But anyway, my son Douglas took this picture. Oh, when he took the picture, we were parked down here, and we walked across. So there's a lot of peat over here that somebody mined a little bit, and fens are a place where groundwater comes to the surface and makes a swampy area, and they're very protected, because a lot of this vegetation here goes back to the Pleistocene, and is the type of vegetation you had here during glacial time. Anyway, he was about a quarter mile southwest here, and I was down here, and they saw him running like mad towards the car. Sure enough, the flies are all over him. Poor guy. Now, this mountain here, Buffalo Peaks, has 2 very thick, you can't quite make them out real good from this lava flows right in the middle of it. And on either side, you got the Mosquito Range to the north and the Kaufman Ridge to the south. And then right in the middle of this thing, this is, for this part of the range, it's more resistant than either the Precambrian rocks on either side. And this is what happened. There was, again, one of those big valleys eroded, And the whole thing was filled with lava and mud flows, mostly lava in this case, because it's very resistive. It's what's called an inversion of topography. What was really originally a valley is now a mountain. And the Hall Buttes down here by Antero Junction on either side of the salt works ranch out there are also indicate that this stuff came that far out into the basin, and there are erosional remnants of the same thing, by the way. This is one, here's town of Como, and this is Boreas stock or sill or whatever, and this is Como Hill. You can see the highway goes down here, and it goes through two sills. I told you the sills are in between rocks, so you see they in this area especially have the 20-degree east dip on them, and you get pretty good outcrops right in there. This thing again is an inversion of topography. Originally, there's a source, apparently it's over by Mount Baldy to the north here, and this was a valley, and it was filled with this kind of material. You see little shards of lava here, but the matrix, look at the matrix in there. It's glass. This stuff was so hot that when it came down, it was so close to the source, in other words, that it just made for a big, huge pile of rock. If you want to go look at this, you can go park at the northwest part of Como and follow the railroad right away and across the south edge of this thing, and it's a short walk up to this outcrop right here. But you don't want to use that rock hammer, by the way. If you do, you'll look down and you'll find your hand full of bleeding areas from rock shards, because it's very dangerous to pound on this stuff. This where I'm jumping down now on County Road 53. Again, we're straight north of Hartselle, and out in the Antero Valley or Basin. And this is another outcrop of that ancestral rocky basement. The intrusive rocks here, they date about 1,700 million years. But this stuff in here is ash bed and lake beds, and it's the same age as the lake beds at Florissant. And in other words, at the same time they had a lake at Florissant, there was a lake in South Park. And you can find evidence of it all over if you know what to look for. On the Elkhorn Road, if you get my book, it shows you where to stop. There's an outcrop of the same type of rock as they have at Florissant. And I gave a talk in Golden one time, and this girl came up there, and she had a box of, a cigar box. And in it was full of beautifully preserved dragonflies that she had found out of that outcrop on County Road 12, anyway, down through there. I've gone out there and got a lot of twigs, fossilized twigs, and a couple little bugs, but I never found any. Dragonflies, I think she cleaned them out. But in this area, you get some light-colored rocks here that are limey, and you can get some fossil algae. I haven't found anything else in this area. In Terrell Junction, where 24 and 285 come together, on 285 about a mile, half mile to a mile, you'll see a lot of flaky limestones in the side, the side of the highway anyway. And that's the western side of the lake. So it covered a huge area up here. You've heard of the rifts of East Africa. Excuse me. They come down all the way. Here's Madagascar. It comes up through here to the Afar area. And then we got the Red Sea, the Gulf of Eden, and you got going up here through the Dead Sea and up through Sea of Galilee. These are rift zones. And what I want to show you that we have rift zones here. San Luis Valley is the northern part of the Rio Grande Rift that goes down the Rio Grande from north to south across New Mexico. Up here in Colorado, it sort of takes an echelon jump and it goes up and it terminates right north of Leadville. But Salida and Buena Vista are right in the east edge of this thing. It was part of an uplift that took place about 25 million years ago. And this is a map that shows color, the elevation, and everything in here, this darker color, is over 10,000 feet. But you see that from east to west, it's just a huge uplift, which what you call a monstrous up. It's an empyrogenic type of uplift. You got the plains to the east and plains to the west and all this stuff. And of course you got 52 peaks in here above 14,000 feet, but you don't have any above 15,000 feet. It's a sort of weird situation that, but this is all formed about 25 million years ago. And your glaciation didn't come into about 2 million years ago. Let's go back here just a second. On this ridge here, Kaufman Ridge, right in here, somewhere down there's Buffalo Peak, but somewhere down here, there's a series of caves called the Porcupine Caves. Anybody been there? These caves are fantastic. They were published in the South Park Symposium of 1999. And if you want to leaf through it after you get done here, I got a clip on it. They were the only place in the world where you get a Pleistocene, complete Pleistocene fauna for a period from 350,000 years ago to 2.1 million years ago. It's geologically, it's very recent, but I have a list here somewhere. Here it is, of things that they found in that cave. The Carnegie Institute and several others have gone, it's on private land along the ridge, and it's in limestone, of course, and dissolved out, and it was found by miners in the late 1800s that were up there searching for gold. I don't think they found any gold in that area. But it had everything in it. All the small animals, frogs, amphibians, and birds, and a list of carnivores is frightening. Plus it had camels. They even found a horse's tooth, which the archaeologists said, well, this definitely sets it up as being Pleistocene in age, way before the present. This is way before what you can measure with carbon-14, for instance. But they said in one place in this article that they collected like 10,000 different pieces of bone and such out of this cave. Really fascinating, Porcupine Cave. And Gary, this thing probably is out of print, but maybe it's in a library. I don't know. But you can look at it tonight afterwards if you're interested in that sort of thing. Archaeologically, it's a fantastic find. The glacial periods, this is the youngest glacial period, and as I said, when you get to Fairplay, there's another edge of the glacier here, and another one right down south of 285 and here, but this is the youngest one. All these different glaciers are fed and become like, here's London Mountain and Pennsylvania Mountain. These are all glacial source areas, and big old areas on the east side of the ridges, usually on the east side of the ridge, and where the glaciers formed and coalesced. So you see a tremendous amount of coalition in this fashion. I have another talk on glaciers if anybody's interested. But this is the aerial view I took from a little airplane one day. This Sheep Mountain right here, you see. And that's the London Fault right across there. Here's up on Mosquito Creek on the north side of London Mountain, Pennsylvania Mountain. It's Pennsylvania. The glaciers moving through here one time after another. When you get here in the afternoon, this whole side of the valley just glistens with the crystals. Here's the one, I put this in because not many people get to see this. You have to go up on top of Mount Ross and then go north to Cameron and then look across the north part of the Middle Fork Valley, and these are the Wheeler Lakes, just beautiful lakes, and cirque-type lakes, and then they have tremendous drop-offs. If you got skill with a four-wheel drive, you can get up there. I don't recommend it because I think the road's so rough it's hard on four-wheel drive. Here's from Windy Ridge, looking down here, and I just wanted to show you. There's the terminal range right north of Fairplay. But then as you come up here, you get the Bristol one, and it goes over here to our cabins over in here. What these are is substage terminal moraines. In other words, this one's probably 25,000 years ago, old, and then the glaciers retreated and then came back forward again, and you get another stage where they sort of stall out, and you get another huge. This Bristol mine, you know, the dredge is right over here, if you know where the dredge is. And then here's oh, help me out. Next town. Alma, my God. And you can see it almost also on one of these, and of course they have gold workings here and a lot of gravel workings now, but it's a different type of substage terminal array because it's got a lot of finer material. But when they were digging into this area, by the way, they found two older glacial scars underneath this thing. And then the next one, big one, is up Lake Montgomery. And if you go around all the valleys around here, they all have these same 3, 4. If you go up Mosquito Creek, you'll see two going up Mosquito Creek. This is something, you go up Mosquito Creek Road on this Mosquito Pass Road, and when you get up to the point where you don't want to take your car any farther because it may not come back down, on the south side of the road, as you go up towards the north portal of the London Mine, you have a beautiful flower garden. And these rocks, by the way, are granites. They're about 1.4 billion years old. So there's a big outcrop of granite in this area. When you park your car down there, you're looking down on some huge beaver dam. Thank you very much for coming.